All right, so for section 3.1, they come back and they go over a little bit more regarding the displacement, the velocity, and the acceleration. Um, Basically, they refer to this diagram down here and they talk about displacement. And so, displacement, right? Displacement is basically where you start versus where you finish. So, uh, where you start versus where you finish is displacement, but it is not distance, okay? Distance, all right, accounts for the amount of distance covered going both directions, whereas displacement only focuses on where you start versus where you finish. So, as an example, just so you're clear on this, like if you were to go from the red light in, or you say you start here at the school, right? You start here at the school and you go clear to Wilkes-Barre and you come back to the school. Well, technically, in that case, your displacement would be zero because the place that you started and the place that you stopped is the exact same location. Therefore, displacement, when you look at where you started versus where you finished, your displacement is zero because those are the same exact locations. Now, that's completely different than distance because obviously distance you have the whole way up, that's all that distance, and then all the way back you have to add that to it, and that would give you your total distance. So that's just kind of showing you the difference between displacement and distance. So in this example, they're calling displacement to be delta r, okay, delta r, so change in displacement basically, and they're going to call r. Okay, r is a vector to be your final displacement, and r sub 0 is your initial, okay? So in this diagram, if this is my initial, right, and this is where my final is, okay, so this is my initial, this is my final, then my change in displacement would be my delta r here, or in other words, final minus initial. Nothing too crazy there. Average velocity we've talked about before. It's simply your displacement divided by your time. Here in this case, they're saying r final minus r initial, so that's your change in displacement. All over final time minus initial time, that's delta t. So again, delta displacement, so change in displacement over change in time. That's going to be your average velocity. Instantaneous velocity we've talked about before. The only difference here is that you're going to let your time period become super small. So delta t approaches 0. So your time period becomes extremely small. One of the things that they don't really do a very good job here of discussing is that sometimes they're going to ask you for your either vertical or horizontal components of velocity. Whoops, I don't know how that got up there. But your vertical or horizontal components of velocity. Well, if we're talking about this, right, we're going to call this a right triangle. This is my overall velocity, right? This is my velocity total. Well, then this is my Vy, and this would be my Vx, correct? So this is your horizontal component of velocity, and this would be your vertical component of velocity. And obviously, imagine that your theta is here. Well, then Vx would simply be V cosine of theta. And your vertical component of velocity would be v sine theta. So it's really just coming back to finding the components, I guess, if you will, of a triangle, right? So V is going to be your overall. In other words, it's going to be like your hypotenuse. Vy would be your y component of your velocity. This is your x component, or you could also refer to this as your vertical component, and this your horizontal component. So this is your horizontal component, and this is your vertical component of velocity. So that's one of the things that they don't really do a good job of explaining here. So I just wanted to touch upon it. Then they go on and they talk about acceleration. Again, no change really here from stuff that we've discussed before. Look, average acceleration, it's going to be your change in velocity over change in time. Nothing has changed there. And then instantaneous acceleration is the same thing, except you let your time become very, very small. So you take the limit delta t approaching 0, just like we did back with the velocity. So nothing too crazy there. And they just, they recap it. They look at displacement. They talk a little bit more about it. So this section 3 section 3 or chapter 3 in general, what they're getting into is, instead of now looking at these different things in only one dimension, we're going to start looking at them in 2 dimensions. So a couple sections back, we looked at things only in the horizontal direction. And then we looked at things only in the vertical direction. And here in the next couple sections, what we're going to do is we're going to start looking at things in both the X and the Y direction all at the same time. Because rarely in life do things happen solely in just one direction. Oftentimes there's more than one direction at play. So, but that is section 3.1.